Welcome to qnawire.
Let's first understand the data. Each leaf has been treated with virus 1 and virus 2. We want to check if the number of lesions or spots caused by virus 1 and virus 2 are the same or different. And since the same tobacco leaf was treated with both viruses, the results are paired. And this helps us compare the differences directly for each leaf. So we'll find the differences between virus 1 lesions and virus 2. And let's do that first. So we have our 9 leaves, and we want the differences. And so the difference for leaf 1 would be 31 minus 18, which is 13. 20 minus 17, 18 minus 14, 17 minus 11, 9 minus 10, negative 1, 8 minus 7, 10 minus 5, 7 minus 6, 11 minus 9. So those are our differences. And we're going to want to calculate the mean of the differences and the standard deviation of the differences. I'm going to use a calculator for that. Or you can just add them up and divide by 9 for the mean, but the standard deviation would be a little more complicated to do by hand. But we have differences of 13, 3, 4, 6, negative 1, 1, 5, 1, and 2. So the mean of the differences is 3.7 repeating, so I'm just I'll go to 4 places. 400 would then be 8. And the standard deviation is 4.0859. And now the test statistic, this paired t-test, is the mean of the differences over the standard deviation of the differences divided by the square root of the sample size. So that'd be 3.7778 over 4.0859 over the square root of 9. So put that into a calculator. It is about 2.77 for our test statistic. So now we'll take that test statistic and you can use a p-value calculator. The degrees of freedom would be, if n is 9, then the degrees of freedom is 8. And we want this at a 0.05 level of significance. So you can use a student t-distribution table, or you can use a calculator or a p-value calculator. The p-value for this is 0.024, which is less than 0.05. And so we would reject the idea that virus 1 and 2 are the same number of lesions. So we would reject the null hypothesis that they would create the same lesions. The 95% confidence level, or not level, but the 95% confidence interval would be the mean of our differences plus or minus for 95%. And 8 degrees of freedom, we looked at critical T up, times the standard deviation of the differences over the square root of the sample size. And the Mean was 3.7778. The critical t is 2.306. Our standard deviation and our sample size. So now into a calculator. 3.7778 minus 2.306 times 4.0859 over the square root of 9 is about 0.64 for the lower boundary. And for the upper boundary, by adding, is 6.92. And since 0 is not in this interval, that means we should reject the null hypothesis that there is a difference. If 0 is contained within this interval, then we would not be, this would not be statistically significant because no difference is within the reasonable range of possibilities.